Hi dear students, welcome back to my session. In our previous session, we discussed a few problems based on the mesh analysis. In this session, we are going to discuss a few more problems based on the star delta transformation techniques and, uh, and the results. So now let me see the next slide. So in previous session, we solved two problems that this session is continuation of our previous session. So find the resistance between the, what is the problem now? Find the resistance between the terminals of battery in bridge network as shown in figure. Here, here let me see the resistance. Here let me see the resistance. Here there are six resistances. Sorry, five resistances. 1, 2, 3, 4, 5. This circuit is named it as called bridge network or bridge circuit. These types of circuits will comes on your next semester. Let me say the subject name is electronics measuring instruments. In the subject, these types of circuits will comes to you. So, but as of now, you have to solve these types of questions. In this question, uh, let me draw. Let me add my marker. This is plus. This is minus. So find the resistance between the terminals of battery. Means this is the terminals of battery. I can say this is the one terminal A. This is terminal B. So how much resistance is there between A and B? This is one terminal. This is one more terminal like this. So your job need to be find this complete resistance between A and B terminals across this. Right. Let me move to the next slide. Let me see the solution. Due to the resistance R3, we cannot solve it by simple series and parallel analysis, right? Because here in the presence of R3, if R3 is not there in the circuit, then it will look like this is series, this is also series, and hence this both are parallel. So you can apply the simple techniques, simple type of techniques like series and parallel. But here those series and parallel is not possible here. Hence you need to be follow advanced way of the reduction technique that is called star and delta. However, we can observe the R1, R2, and R3 are in delta. Right here, you have to see. Let me remove my marks. You see R1, R2, R3. These three are in delta. Look like this, that is delta, right? And this is also delta. R4, R5, R3. Your job need to be solved either maybe this circuit or this circuit. Your job need to be reduct the delta into the star, either maybe R1, R2, R3 or R4, R3, R5, right? But here I did only R1, R2, R3. Then my circuit is look like this. Selecting the delta to convert the star, this delta I highlighted with my dotted lines. Please observe here. You can select any one of the delta, either maybe A, B, C, or let me say this is D, or B, C, D. You can take any one of the, but don't do at a time both these deltas. It will give wrong answers. To be clear, don't do deltas at a time. Right. Select the delta ABC, then it will frame like delta to star. What is the formula of delta to star? What is the formula of delta to star? Try to remember that formula. I already said so many times. Those formulas are very important. We need to be remembered. So now I'm finding this means for finding of this arm, it is multiplication of RAB, RAC by total of this RAB, REBC, RCA like this. Right? The finding of RA. I'm finding of this RA. Then it is nothing but the adjacent multiplication of the adjacent arms by the total arms, summation of total arms. So that's what I wrote here. RA is equals to RAB, RAC by RAB plus RBC, RAC. So you should consider this is suffix term. You should not write like this. Please, you should not write like this. This is completely wrong. Should always use this as a suffix term. Most of the students they used to write like this. Means RAB. There is no, there is not, there is no meaning of like this. If you mention RAB instead of mentioning suffix. So you should mention suffix term like this. Hence my RAB is nothing but RAB into RAC by RAB plus RBC plus RAC is equals to RAB value, you know, 12 into 18 by 12 plus 18 plus 6. 12 into 18 by 12 plus 18 plus 6. It will be 6 ohms, right? So 16 by 36 is equals to 6 ohms. Now you got only one resistor that is called 6 ohms. Next, you need to be find RBs, right? If I say this is RB is nothing but a 12 into 6 by 12 plus 6 plus 18. 12 into 6 by 12 plus 18 plus 6, right? Then you will get RB is nothing but how much value? 2. Let me write that is 2. 2 ohms. Next, what about the RC? RC is nothing but 18 into 6 by 18 plus 12 plus 6. 18 into 6 by the denominator value will never change. The numerator value is going to be changed. Why? Because based on the changing of the arms, this value is going to be changing. That is the reason that in the denominator, if you find only RA, if you finding of RA of denominator, then you can write those same RA denominator for RB and RC. Instead of writing this all lengthy equation, you can write directly 36, because you know that the denominator is nothing but summation of all the arms. It's only 2 by 36. What about RC? 3. RC is nothing but in this value it is RC 3. Now you need to be redraw the circuit again with the eliminating of this delta connection into new model, that is star connection. Again I will repeat it. You should redraw the circuit by eliminating of 12, 18, 6 into 6, 2, 3. Means this connection will not be appear on your next on your next figure. Right? Let me see that figure. I changed that connection RA, RB, RC. Instead of as of now, before that connection is look like this, right? I change it into like this. Say, just I converted. Why I converted delta to star or star to delta? Finally, for to make the circuit into the series parallel. Then for the making of circuit into the series parallel, I am doing the star and delta model. Okay, so this is star again. Here for the star connection of ABC, here some magic is happened already. Here this is RB and R4 is series, right? There is a no circuit. This is series. Again, this both are series, RC and R5. Are you clear? This is series. This is series. Let me observe the circuit also. Connect the delta. Connect the obtained star in place of delta. As of now, I did that only. You should add this plus and minus sign. The signs are very important. Even though there's delta star or image star model, that doesn't matter about the technique, but signs are very important. Here I converted, you should write clearly delta connected converted to star. You should write this wording is very important while you are deriving these types of problems, right? Then connect the obtained star in place of delta as shown in figure. So instead of delta, I converted into the star just by making RA, RB, RC. Earlier that connection was RAB, RBC, RCA. Now the connection of RA, RB, RC like that. So after that, substitute the values in star as shown in figure. Now I substitute the value R6, 3 and 2. Now we can apply simple series parallel techniques and find the resistance as seen by the battery. That what I said. Here, whatever you are applying the star and delta, finally the circuit will be look like a series and parallel. Then you can find the exact equivalent circuit across any terminals, um, uh, any points between any points. So that is very easy way of finding of the total equal resistance between any points. Now I applied the series and parallel. Sorry, now before that finding of the before convert before look like a series parallel, I applied delta to star. Then my my circuit is going to be simplified. Now here you can easily indicate it. This is series because there is no diversion of current. The same current which is traveling through RB and R4. Here also the same current is traveling through RC and R4. So that means this both are series. Hence, after series, after converted this 3 plus 12 means 15, 2 plus 18, 20. This 20 and 15 will be current diversions. Both are have the different currents, means both have the comes under category of parallel. That is the reason we can apply series and parallel techniques and find the resistance. Let me see the next slide. Right now, this is 18. This is 12 plus 3 is nothing but a 15. 12 plus 3 is 15. 18 plus 2. In the circuit shown in figure, the 2 ohms and the 18 ohms. Why I made everything in wording means you are just learner. If I didn't mention like this of wording, you will directly do these steps on your mind itself. That what I am not expecting from your side. I'm expecting you guys need to be write each and every steps in wording and in diagrammatical way. I don't want any shortcuts. This is not MCQs. This is a way of representing on your examination papers. So that is the reason you guys need to be clear each and every step on the paper itself, right? In the circuit shown in figure, 2 ohms and 18 ohms are series, and 3 ohms, 12 ohms, 3 and 12. Sorry, that is not 8. 3 and 12 are in series. Then two series combinations are, means 20, this both are parallel, right? Means 20 and 15. After doing 20 and 15, 20 and 15 divided by 20 plus 15, you will get one value, that is called, that value is 8.57. The resulting value of 8.57, which is series with 8.57, which is series with the 6 ohms. Hence, you applied series after parallel, then series, parallel, then series. This way of techniques you applied. Before this technique, you applied star, sorry, delta to star. So you applied four techniques. One is delta to star. Next series you applied. Next parallel you applied. Again you applied series. Four ways of steps you applied for the reduction of this two terminals A and B. Sorry, A and D terminals. So hence my total resistance between these two terminals is 14.57 ohms. My total resistance between these two terminals are 14.57. After the completion of this reduction, you need to be redraw the circuit. That is called final circuit. So let me draw the final circuit by indicating of this your result values. If your time is there, then you can find the current also. Current is nothing but I is equals to V by R 10 14.57. You will get the current value also. How much current value I can get? 0.68. 0.6. So if in case if we ask the current flowing through this complete uh, current flowing through between A and A and D terminals, A and D terminals, you can find this types of answers. So if he is not asked any current, just he asked only the equivalent resistance between the uh, battery terminals, just like A and B. You can find that value like this. So but whatever he is asking, but finally you need to be represent the values and your final circuit. You should not leave by writing this 14.57 amps ohms across A and D. Don't leave like this. This is unfinished way of problem. In the finished way of problem will start with the circuit and with end with circuit only. That is the complete finished way of complete representation of your problem solving. Don't finish like this. Finish always in circle way. Right? Then it is look like some symbolical way. Right. Next, let me solve one more problem. In this problem, let me read the problem. Find the equivalent resistance between A and B in the given network. So now he wants to know the A and B. Before, is there any possibility of applying series in parallel in the circuit? Let me see. If any possibility is there, then we will apply series in parallel before we are applying star delta to star transformations. So first, your job need to be apply series in parallel only. Don't go directly delta and star. That will be lengthy process, right? Always we are using the techniques for the saving of our time only, right? Here, find the equivalent resistance between A and B in the given network. This is A and this is B. Let me find any approaches we can use. Let's. There are three ways of reduction of technique. One is series, one is parallel, third one is delta to star, or star to delta. These are the three ways of reduction of any series, any network. Here, let me see any technique, anything we can apply series in parallel. Here, this 4 and 4 are series. No, because current is not going in same this both resistors. Even the resistance values are same because the current I is going to be split into the I1 and I2, right? Hence, this both are not series, not parallel, right? This finished. Next, what about this two 4 ohms and 8 ohms? Is both are in parallel because the same opposite currents is going to be flowing. Because here the current I1 is flowing, here the I2 is flowing. Is 4 and 8 is both are parallel? No. Why? Because the one terminal of these two are connected at this point, but the second terminal of this 4 and 8 ohms are not connected to the same point. Here the 6 ohms is present. 6 ohms is exists between 4 and 8. That means this 4 and 8 are not parallel. Again, I will repeat it. Since this one side of, let me say this is 1 1 dash, this is 2 2 dash terminals. 1 and 2 are both are connected to the same point, but 2 and 1 dash and 2 dash are not connected to the same point. Rather than that, it is connected between the resistance, that is 6 ohms. It means these 4 and 8 are never be parallel, since it is this complete circuit is not parallel, not series. So hence it will be some other way of representing. So let me think that way in next. But before that, let me conclude that series and parallel either maybe we can apply or not. Next. So here, what about this 6 ohms? 6 ohms is parallel to this? No. Series to this because the same current is traveling this? No. Here there is not a same current. After current is coming from here, it is going to be split like this, here and here. These both are not parallel. These both are not series, and 8 and 6 are not parallel. 8 and 6 not parallel. Let me see 8 and 4. 8 and 4 also not parallel, not series. Why? Because the one of the terminals are connected to the same point, right? But secondary side of the terminals are not connected to the same point. Rather than that, it is connected between the 6 ohms resistor. Hence, entire this network we can't apply series and parallel. This circuit is not in the position to apply series technique or parallel technique. So then we are going to be approach another way of taking, that is star to delta or delta to star. Let me see. First, whatever the technique, whatever the circuit is given, that doesn't matter. First, your job need to be find is we can apply series or method or parallel method. Your job need to be check series and parallel techniques. If the technique is feasible, then go for the techniques. If the technique is not feasible, then go for star and delta. Simple. Right. Next, let me see what solution. Now I am going to be solve this network by using delta to star conversion. Here there is a deltas are there. 4 6 8 1 delta. If I draw like this 8, it is look like a delta only, right? Next to 8 6 4 one more delta, right? If I draw like this, it is look like delta only, right? Instead of writing, instead of drawing 4 ohms like this, I can draw 4 ohms like this also, because same way of approach. Just I cut down some wire, then I make that wire into direct connection of like this. So that is theoretical and practical, that is possible only. So instead of drawing like this, for the look like a delta, I made this connection like this. Hope you clear. In this, look at this problem carefully first. right? Now A and B. I redraw the circuit instead of 4 like this. 4. Now here this look like a delta. I convert it into the star like this. You can see on the next figure here. But here instead of mentioning RA, I mentioned here RA, RB and RC. For finding of RA, 6 and 8 by 6 plus 8 plus 4 means 18. Directly you can find this value. Next, RB means this 2. 8 into 4 by 18. Next, RC. 6 into 4 by 18. Then you got RA, RB, RC. Here I drawn only figures, means networks. But here what I am trying to say is, in our electrical circuits, theoretical is not important. The networks which you are going to be drawing is very, very important, right? For finding of RA, same. For the value of new star connected resistance are finding through direct formula of delta to star conversion as shown in figure below. Shown below. So next, RA is nothing but 2.66, RB 1.77, 1. Now I substitute this new star connected star conversion new star in our in my circuit. This star is going to be showing like this. This is after conversion of delta to star. You can do this also, but while you need to be choose either maybe one delta or this delta. You should not do these two deltas at a time. If you do two deltas at a time, it will be give wrong answers, because 6 ohms you utilized in the circuit, also you are utilized the 6 ohms in this circuit also, in this reduction. Means you are using 6 ohms in the two circuits for the reduction of techniques, that will give wrong answers. So that is the reason you should pick up only one delta connection instead of two, right? Hope you clear. Then it will, the value is look like, here you can see this is look like a series. After I'm adding the values of my star connection 2.66, 1.33 and 1.7. So then the same current is traveling through this complete branch. Hence I'm going to be adding these two values of resistances. One is 4 ohms and one is 2.66. Then it will be 6.66. Then what about this? This is also series, comes to the series, because same current is traveling through this entire branch. Then 8 plus 1.33, it will become a 9.33. Now these two circuits are look like parallel, I can say. How? Because one circuit is 6.66, another value of branch is 9.33. Then these both ends are connected to the common point. For this end, connected to the common point. For this end, connected to the common point. Hence, this both are comes under the category of parallel only. If I do this parallel application of this technique, then 6.66 and 9.33, it will become a 3.88. It will become a 3.88. Then the resulting of 3.88, which is series with your 1.77, just I am doing this only. As of now, I am performing the technique of this connection only. After the connection, after the reduction, the value is 3.88. The resulting of 3.88, which is series with the 1.7, also which is series with the 4 ohms. Then you are applying finally series. What analysis you use? Delta to star. Then after that, series connection. After that, you used parallel. Then after that, you use series. So you use total into the 4 steps. So finally, after conversion delta to star, star to delta, it will look like a series parallel series or parallel series parallel. Like this connection, you will get it. So hence, After when to measure the resistance between A and B, you need to be add these three values of resistance. One is 4 ohms, 3.88 and 1.77. So RAB equivalents or R equivalent. R equivalent is nothing but a RAB. Then it is nothing but summation of R1 plus R2 plus R3. R1 plus R2 plus R3. 4 ohms, 3.88 ohms, 1.77 is equals to 9.65 ohms. You need to be draw the your final circuit. This is A, this is B. Value is 9.65 ohms. This is current. There is no current. Sorry, because there is no battery, hence there is no current. So hence the resistance is nothing but a R suffix AB. Some books they used to prefer RAB or R equivalent. Both are same. The wording both RAB or R equivalent wording is same. So you can write either R suffix AB or R suffix EQ. Means EQ is nothing but R equivalent. So this is way of solving the reductioning of any resistance parameter, either will be in connection delta, either will be in connection bridge network or some other in critical way of network circuits. So you can use series parallel and delta star. If series parallel is not possible, you can use delta to star. So the circuit will be comes under these three categories only. Either maybe series, parallel, or delta to star, star to delta. In any circuit, in entire the electrical circuits or any our electrical and electronic engineering branch, circuits comes under this branch. It will comes under this techniques only. Either you can apply series or parallel or delta to star, star to delta. So if you hands-on free experience on this three types of circuit, three types of techniques, you will able to find the current of the any branch by using these reduction techniques. So let me look at these problems again. First problem, we observed the only conversion of delta to star. Again, sorry, first problem we choose only one of the delta among the two. We choose ABC instead of BCD, right? ABC. You can use BCD also. BCD after the using of BCD, it will give same value. Let me try for you guys. Let me try BCD. Let me remove my marks. Let me try BCD. For BCD, 18 into 6. 18 into 6, how much? Let me do calculate. 18 into 6 by 18 plus 12 plus 6, 36. The value will be 3 of this. This is 3 ohms. What about this 12 into 18? Next I am doing this one. 12 into 18 divided by 36. 12 into 18 divided by 36. The value will be 6 of this. Next I'm going to be do 12 plus 6 ohms. Then sorry, not plus 12 into 6. 12 into 6 divided by 36. Then that will be 2. I'm going to be redraw the circuit like this. This is 3. This is 6. Sorry, this is 2. This is 6. Whatever these values are given itself on given in problem itself only 12. It's 8. This is 10 volts. Here, this is my star, right? This. I use this star only. I represent it here. This is A, B, C, D. This is neutral. Let me take the end. So here, this both are comes into the series. 12 plus 3 is nothing but 15. It will be 15, and 18 plus 2 is 20, right? Then this 8, 15 and 20 are again parallel, because this is connections are into the same side is connected to the common point. Then the A and N will become a parallel. Sorry, the elements between A and N, the elements between A and N point will be comes under the parallel category. Then I am doing the parallel way of technique. Then it will be 15 into 20 divided by 15 plus 20. Then it will be 8.517. The entire network between these two is 8.571, right? About this, the resistance between A and N. I will repeat it, that the resistance between A and N is 8.57. Now again, I'm going to be redraw the circuit by making like this. I'm going to be redraw circuit like this. Right. This is A, this is N, A, N, and this is D. The circuit between A and N, the resistance is 8.571, and the resistance between N and D is 6 ohms. Now these two are in comes series technique, series way of approach. Then 8.571 plus 6, right? Then it will become a 14.57. The total resistance between these two points A and D is 14.57. Is my answer is correct or not? Let me check. Right, 14.57. Right. So what I want to conclude is you can approach any one of the delta connection, any one of the star connection. You should not do both deltas at a time. So you can follow any one of the you can follow down delta or up delta. That is your interest, right? Hope you clear. You can apply that type of technique for this also. You guys need to be do for this 8 ohms instead of the 14 ohms. Then you will get same answer, right? You will get delta to star connection. After that, do some mathematical calculations. Then after that, you will get this types of answer 9.65. But the final circuit is same. So I want you guys. I'm giving some assignment to you. You need to be do it to yourself. This is your task. What is the assignment? Find the current flowing through the 6 ohm resistor shown below. This is the resistor. This is the circuit. This is the network. You need to be find the current flowing through this 6 ohm resistor. This either maybe this direction. I'm not giving the directions. Either maybe this direction or this direction. The direction is need to be you decided by your answer. Your answer is same as your approach, then your answer is correct. If your answer is not giving the proper way of signs, means a negative sign, means your approach is wrong, like that. Your answer only going to decide the direction of the current through 6 ohms, right? I'm not giving the directions, just I show in the 6 ohms resistor only. So I want you guys need to be do this. This is these types of problems which comes under your examination point of view. This is very, very important problems, right? You can use any one of the method your interest. You can use mesh analysis, or you can use loop equation based on the loop currents or branch currents. You can use nodal AI analysis if if you're very comfortable on that method also. Then you can use any method among the 12 methods. That is your interest. So but I want you guys do it yourself. Don't copy from others, right? Hope you clear. That's it. This is today's session. Hope you understand all the problems. I want you need to be clear about the delta to star, star to delta, and just practice more and more problems on the delta to star and the star to delta conversions. That's it. Thanks for your time. Hope you enjoy the this session. Thank you a lot. Bye bye. Have a good day.